Hi, I'm Dr. Papia Bhattacharjee. In this problem, we have to evaluate the area of a region, and the region is right here, using double integral. So notice the region is bounded by y equals x and the line x equals 4 and x-axis. Okay, so it's a triangular region. Now, we have to use double integral. So we have to draw a rectangle, which is a representing rectangle, inside that region and then figure out what are the x bounds and the y bounds using that rectangle. Okay, so let's do that first. Let's draw a representing rectangle, say wherever you want, but remember inside the region. Okay. So that's my rectangle. And the way I drew it, it's vertical. And so the width of this rectangle, say the width is delta x. Okay. Since I chose to draw it this way, that means I want x or dx, that to be my outer integral, since we'll have two different integrals. Okay. So using this rectangle, let's figure out what are the x bounds and the y bounds. Okay, so for x bounds, x is right here. So we just have to see the region lies between which values. So it starts here at y-axis, so x is 0, and it ends at x equals 4. So the upper bound will be 4. So x is between 0 and 4. Now what about the y bounds? So you have to look at the length of this rectangle. Okay, and see the y starts again at x-axis, so that's where y is 0, so that's the lower bound for y, and then the upper bound is the line y equals x, because this rectangle stops there at that line. So x is the upper bound for y. So now the setup for computing the area using double integral. So we have double integral. Remember, x is the outer variable. So for the outer integral, we write the x bounds 0 to 4, and dx will be the outside one, and the inside one is dy, and its bounds are 0 and x and dy. Note that this is a correct setup to compute area, because what is dy times dx? This rectangle has a width of dx and the length of dy. So this is just the area of this one representing rectangle. And then integral basically means addition. So we are adding all these areas of all these rectangles that we can draw in the region, covering the entire region. So that will give us the total area. So that's why this is the setup to compute the area of that region. Okay. Now, let's just evaluate the integral. Remember, for double integral, you ignore the outside one first. You just evaluate the inner integral. So let's only concentrate on 0 to x dy. Right? So we get y, and then you have to evaluate from 0 to x, and you keep dx as it is. Okay. So we have y, you just plug in x and plug in 0 and then subtract. So we have x minus 0 dx, and notice this is just a single integral, and this is 0 to 4 x dx, and using power rule, this is x square over 2 from 0 to 4. So plug in 4 for x, you get 4 square over 2, minus plug in 0 for x, you get 0 square over 2. So this is just 0, and 4 square is 16. 16 over 2 is 8. And since this is area, the area is 8 square units. Okay, so we have the area of this region. Now, before I finish, just notice something. Notice that this region is just a triangular region, and we can see right from the picture that it's a right triangle. So sometimes if you have a simpler region, you can even check your answer with a geometrical formula that we can use to evaluate the area in the first place. So do you remember how to evaluate area of a right triangle? So what is the area? It's just half times the length of the base times the length of the height. So what is the length of the base? See, it's 4 units. So this is just 4. And what is the length of the height of this triangle? Well, since this is y equals x, x4 gives you y4 as well. So this is also 4. So this should be the area. And half times 4 times 4 is 8. So this tells us that we did get correct answer using the double integral. Thank you.